The warning, so the project is of 6CS660 on City Bike NYC. This project records one month record of the City Bike, which is a service in New York City, and the total number of rows in the data set is almost 30 lakh, and so in which we have done all the types of analysis that is covered during the course. The project goals include exploring the NYC city bike usage patterns across multiple location and rider segments, practice a full stack data stack, pandas, MRJob, Spark RDD, data frames, graph, and Sedona. Deliver explain insights and R-day queues, route pairs, network edges. The data sources include the primary city bike NYC trip data, and the key fields are ride ID, timestamp, start and station, and latitude, longitude, writable type, member casual, and derived feature is trip duration minimum and R-day queues, route pairs, and network edges. Methodology includes pandas, ingest, clean, schemas, checks, EDA, MRJob, extra validation, summaries, Spark RDD and data frames, scalable transforms, that is map builder join, aggregations, SQL-like analysis, graph, station-to-station network, centrality, PageRank and triangle counting, spatial convex hulls and buffered hotspots by user type, overlaps is equal to shared zone. So here we can see a visual of rights by user type, based on which we can determine which type has highest. Similarly, we can see here based on the bike type, where electric bike has a higher number of riders. And if we see the next slide, in next slide we can see that the rides by hour of the day, that is the busiest hour is 17, that is 5 p.m. And in the next slide, if we see the rides by day of the week, that is Monday is the busiest day of the week. Similarly, in the next slide, if we see the members versus casuals by day of week, we can see that the members basically are more there into it. And the top 10 stations, the busiest stations is the West 21st Street and 6th Avenue. And also in the end stations, the same prevails. And if we see the top 10 routes from start to end, the Central Park Street Avenue is the highest. And if we see the MR job average trip duration by user type, we can see that the first user is the highest. And Spark highlights, if we see the RDT operations map filter to derive R-bins and compute windows joins to enrich station metadata. Actions used are count, take, collect, top to validate and publish quick stats. Data frames equal group by aggregate for top K stations. Routes windowing for R-day analysis. Here we can see station to station pairs of edges samples, and here we can see the graph results of PageRank and triangle participation, that is the top 15 results. And if we talk about spatial, that is Sedona, methods and findings, built point geometrics for trip starts per user type. For core areas, reprojected EPSG 3857 created 250 million buffers around top 30 stations unioned, computed convex hulls and overlap areas in meter square, member casual spots and their shared zones. The observation is that member hotspots align with commute corridors, casual buffers expand into leisure. And key insights are that members dominate rides but have shorter average durations, casual ride longer, and demand spikes at 8 to 9 a.m. and 5 to 7 p.m. Friday and afternoon also elevated. Staffing is reduced to queue. Top station cluster in Midtown Central area, and network centrality and triangles point to dense in Midtown. And if we talk about reproducibility and repo, it is divided into six sections in the notebook, but the sixth section is in second part. And The repo is also available at GitHub. And and if we talk about the next steps are ingesting more months for seasonality, model daily demand and weather sensitivity, add station level rebalancing recommendations and simulated pickup drop off imbalance, deploy a small serving API, that is fast API, with pre-computed insights and station search. And thank you for your time.